Here we are on our review worksheet. Let's take a look at one problem from each section. Hopefully this will give you an opportunity to see how some of these are done. Let's look at number 1. It gives us that 8 and 9 are two sides of a right triangle. There's a couple cases here. They could be both legs, in which case we're looking for this side over here, and we would set it up 8 squared plus 9 squared equals x squared. 64 plus 81 equals x squared, and I get 145 equals my x squared. So I get the square root of 145 is one of the answers, which is about 12.1. The other option is that this 9 is the hypotenuse. So there's my right angle. This is the 8. This is the hypotenuse. And this is the side that we're looking for. In that case, we would set it up 8 squared plus x squared equals 9 squared. And we get 64 plus x squared equals 81. Minus the 64 from both sides. And I get x squared equals 17. Square root of 17 is that other x. Question number 7. They asked us in question number 7, given these lengths of the side, determine what kind of triangle it is, acute, obtuse, or right. Well, the first thing we have to check before we do either of those is, do the two shorter sides greater than the hypotenuse? Remember the tent. If we have a tent with the two sides shorter than the hypotenuse, then the tent won't go up. Well, this is not a triangle. On number 9, they're asking us to solve the triangle the way we were doing in the previous chapter. Let's take a look. SR is 13. SP is 3. And we're going to find RP. Well, if we look at this, this would be the right angle. This would be the hypotenuse. So for number 9, all we have to do is 3 squared plus 13 squared equals c squared. And I get 9 plus 169 equals c squared. I get 178 square rooted is my c squared. For this one, for number 13, they're asking us to solve the triangle. So we're going to be finding all three angles and all three side lengths. DF, they tell us, is 19, and angle D is 66. We're going to find that angle G, because it has to be complementary, would be 24. So my three angles are 24 degrees, 66 degrees, and 90 degrees. Now we need to find some side lengths. Let's get me a calculator. There we got it, the calculator now. First one we're going to find here is A. This is the adjacent over there. Adjacent, and this is my, we'll call it opposite. And the way we would set that up is the tangent of 66 degrees is equal to the opposite over the adjacent. If I multiply both sides by 19, I would get 19 times the tangent of 66. On my calculator, I take 66 tan times the 19, which gives me 42.7. The other one that we need to find is the hypotenuse here. Because this is the hypotenuse, this is the adjacent, I'm going to use my cosine. To solve that, I'm going to multiply by c and divide by the cosine of 66. And I take 19 divided by 66 cosine equals, and I get 46.3. So my side lengths are 19, 42.7, and 46.3. Next one we're going to do is we're going to find the area of this regular 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decagon. To do that, since we are given the apothem, we're going to find the perimeter, because remember our formula is area equals 1/2 the apothem times perimeter. This is the nice case where they give us the apothem. We need to find our central angle in here. So I'm going to take 360 divided by the 10 sides gives me 36. Remember, this angle that we use in here is only half of that central angle, so that's going to be an 18-degree angle. So when I set this up, I'm going to use the tangent of 18 degrees is equal to the opposite, which would be this x, over the adjacent, which they tell us is 6. So when I solve this, I get 6 times the tangent of 18. So I'm going to go 18 tangent times 6 equals, and I know that this little am in here is 1.94 blah, 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 blah. Since there's 10 sides, there's going to be 20 of those lengths. So I'm going to then multiply it by 20 because there's two of those per side, 10 sides. And so I know that the perimeter now is that 38.9903, 38.9903. And I'm going to find the area 1/2 the apothem 6 times the perimeter 38.9903, and I'll let you get that on your calculator. The next one we're going to do here is where they give us a OA, which is the radius. Remember, when they give us the radius, this is the one where we have to use the cosine and the sine. Let's set that up. Remember, this is my apothem, this one is my x that will turn into the perimeter. So when I set it up, I'm going to have the cosine of, let's find out how many sides this is. 1, 2, 3, 4, 5, 6, 7, 8 sides. 360 divided by 8 gives me 45. This angle, of course, is half that, 22.5. So I'm going to use 22.5 degrees equals the adjacent over the hypotenuse. And to do the other one, I'm going to say the sine of 22.5 is equal to the x over the hypotenuse. So for both of these, I'm going to have 14 times the cosine of 22.5 is my apothem. 14 times the sine of 22.5 is my x. When we multiply that by 16, twice the number of sides, we will get the perimeter. Let's get the calculator up here and see if I can do that. I have 22.5 cosine times 14 gives me 12.93 for the apothem. And the other one, let's move this out of the way, I get 22.5 sine times 14 equals, that's the length of this x over here. We know since there's 8 sides and 2 of these x's per side, I'm going to multiply that by 16 to give me my perimeter, which is 85.721. 85.721. This is my apothem. This is my perimeter. 1/2 of the apothem times perimeter. And again, I'll let you do that. 28. A regular 11-gon with side length of 19. This is a little bit more interesting because they don't give us the whole picture. We know that they're going to have a triangle, and the side length is going to be 19, which is going to make half of it 9.5. We can find our central angle by going 360 divided by 11, which gives me 2.73 degree angle. So my central angle is going to be 32. When I divide that by 2 to get the angle, I get this angle in here is going to be 16.36 degrees. So we're going to use that when we find the apothem. I know that to get my perimeter is going to be relatively easy if it's 11-sided polygon and there's 19 per side. I know that my perimeter is going to be 209. The last thing that we need to find is that apothem, so we're going to put an A in there, and we know we'll use trig. Tangent of 16.36 degrees is equal to the opposite over the adjacent. If I take and switch, I get 9.5 divided by the tan of 16.36. Let's get my calculator out here. I get 9.5 divided by 16.36 tan equals. So my apothem must be 32.36. So here's my apothem, here's my perimeter. 1/2 the apothem times perimeter will give you your answer. For number 29 here, they tell us that AB is 3, they tell us that DA is 1, and they ask us to find the radius. So there's a radius, there's a radius. We know that the tangent and the radius meet at a right angle, so we have a right angle there. So we're going to say x squared plus 3 squared equals x plus 1 squared, just using Pythagoras. So I get x squared plus 9. Remember, we would FOIL over here, so I get x squared plus x plus 1. Subtracting x squared from both sides, I get 9 equals 2x plus 1. 2x equals 8. X must be 4. This one, I think we've talked about this. This was on our last test. We're going to say that GC is 4 because it's tangent to the circle. This would also be 4. GF is 13. If this part of it is 4, then this would have to be 9 to make the total of 13. If that is 9, then this is 9, and so on from there. And the last one that I'm going to do today is if this BAC, it's an inscribed angle, is 47, find the arc. The measure of the angle is 47, so then the arc would have to be twice that, or 94 degrees. Good luck.